Hello everyone. In this tutorial we are going to see how to evaluate the prediction power of regression models. For this purpose we are going to use something called R squared. So what is R squared? R squared is a statistical measure that represents the proportion of the variance for a dependent variable that's explained by an independent variable. Wow, that sounds complicated. It's very simple. R square only measure the variance in the dependent variable that can be explained by the independent variables. In other words, we said before that independent variables, when they have impact on the dependent variable, a change in these independent variables can change the dependent variable. But the change is not 100%. So it doesn't mean that if we change the independent variable that change will be 100% reflected on that dependent variable. It's only a portion of the change, is part of the change. So R squared measure that part and tell us how that change in the independent variables can affect, or to which level that change in the independent variables can be reflected on the dependent variable. So based on that, R squared equal explained variation divided by total variation, and that's exactly what we said. It's only a portion. The explained variation is portion of the total variation. So when we divide this number by this number, we will get a percentage. And based on that, that percentage is always between 0% and 100%, or we can say between 0 and 1. 0 indicates that the model explains none of the variability of the response data around its mean. In other words, independent variables don't have any impact on the dependent variable. So if these independent variables go up and down, their values change all the time, they don't have any impact in the change of the dependent variable. So when we got an R squared equal to 0%, that means the prediction power of that model is 0. And when R squared equal 100% or 1, that indicates that the model explains all the variability of the response data around the mean. In other words, these independent variables have 100% impact on that dependent variable. And honestly, there is no model has 100% R squared, because 100% squared, that means the prediction power of that model is 100%, and there is nothing like that. If we reach to something 90% plus, that considers a perfect model. And anything between 70 to 80%, that means this is a really good model. 60 to 70 something is acceptable. And when we start going less than 50%, prediction power of that model is started to be very poor. Let's see here how the R squared is calculated. And we say the values are located outside the slope line are the actual values, or y, and the values are located on the slope line are the predicted values, or y hat. And the difference between them is residual. And we could calculate the base slope line based on the residuals, sum square of the residuals. Now we need to calculate something else, which is the difference between the mean or y bar and between these actual values. And for this purpose, we draw this horizontal line exactly in the middle on the average. So this horizontal line represents y bar, or the average, or the actual values. So now we need to find the difference between any actual value like this value or this value and the y bar or the mean. And we are going to find the first difference and square it, the second one and square it, the third one, until we got all the differences between the actual values and the y bar. And we are going to square these differences and find the sum. So we'll get sum of square. So after we got sum of y minus y bar squared, we can now call it sum squared of total. Sum squared of total equal to the sum y minus y bar squared. And you remember that sum square of residuals equal to the sum y minus y hat squared. So r squared equal to 1 minus ss residuals divided by ss total. This value will be a percentage, and it will be the r squared. And you don't need to do any of these things. Everything will be calculated in the computer. Nothing need to be done manually. There is some other measure we call it adjusted r squared. And adjusted r squared is something is more accurate compared to the r squared, because when we have more independent variables, these independent variables are going to affect on the value of the r squared. And the statisticians found a formula to mitigate or to reduce the effect of the number of these variables to come up with the more accurate r squared. And they call it r squared adjusted or adjusted r squared. And this is the formula: y minus r squared times n minus 1 divided by n minus p minus 1. R squared is the sample r squared, which is the first value that we found in the previous slide, r squared value. And p number of predictors. Predictor means the independent variables. And n is the total sample size. So simply after we find r squared, we put it here in this formula with the number of predictors and the total number of sample size, and finally we'll come up with the adjusted r squared. And usually if we want to evaluate the prediction power of a regression model, it is better to look at the r adjusted because it has better indication than r squared.